So, in this lecture we will show you how to convert a finite automata to a regular expression and vice versa. Now, to convert a finite automata to regular expression, we need to use Arden's theorem. What is Arden's theorem? Arden's theorem tells you that if P and Q are two regular expressions over sigma and P does not contain any lambda, then an expression that is R equal to Q plus RP means the addition of two regular expression Q and P will also be a regular expression that can be rewritten as R equal to QP star. So, how can you derive R equal to QP star from R equal to Q plus RP? So, let us see that one. So, if we write R equal to Q plus RP, which is a kind of recurrence relation, now replacing this R with Q plus RP, then I am going to get QP plus RP square. Now, again replace this R with Q plus RP, then I am going to get Q plus QP plus QP square plus RP cube. Again replace this R, Q plus QP plus QP square plus Q plus RP into P cube, then it would be QP plus QP square plus QP cube plus RP to the power 4. So, in this way, in the next replacement, I am going to get QP to the power 4, then RP to the power 5. So, if I take Q as common, then what I am going to get 1 plus P square plus P cube up to dot dot infinity. Right. Now, if I replace this 1 with lambda, because we know that the value of lambda may be 0 or 1, but the length of lambda will always be 0. So, I am replacing 1 with lambda, then I am going to get lambda plus P square plus P cube. Obviously, this is not a plus, this is actually union. So, the union of entire expression will be P star, right. So, I am getting this expression R equal to QP star from R equal to Q plus RP. So, hence it is proved. Now, using this equality or expression, so we will convert a finite automata to a regular expression. So, let us start with an example. Now, before applying Arden's theorem, we need to check that is there any inaccessible states are present within this finite automata. And another thing is that the finite automata may be an NFA or a DFA. In this case, it is DFA, but we may need to convert NFA to regular expression, and in that case also we have to use Arden's theorem. Right. Now, what is inaccessible states? As we have seen earlier that an inaccessible states are the states which cannot be reached from the initial state either directly or indirectly, or if it is reached from the initial state, it cannot go to the final state or directly or indirectly. Now, look at this in this this state Q4, the Q4 we can reach to Q4 from Q1. Q1 is the initial state through Q2 as well as from Q3, but from Q4 I cannot reach return back to Q1 because Q1 is the final state. So, Q4 is the only state which can be reached from Q1, but from Q4 I cannot reach to Q1. So, it is an inaccessible state. So, if we find out any inaccessible states, then outright you can remove that particular state. So, let us remove Q4 and all its edges. Now you can apply the Arden's theorem. Now I have to write the expression for all the states. Suppose what is the expression for Q1? Q1 expression will be what are the edges that are coming to Q1 through different states. I have to write that particular statement. Suppose if I give B to Q2, I will reach to Q1, as well as A to Q3, I can reach to Q1, as well as if I do not give any input, that means if I give lambda only, that case also I can reach to Q1. Okay. Now let us see what should be the expression for Q2. Now if I give A to Q1, that case also I can reach to Q2, and Q3 if I give B to Q3, that case also I can reach to Q3, right. Now for Q4 there is no expressions are present. Now what I will do that what should be your final regular expression? My final regular expression will be the regular expression in terms of Q1 without any Q2 or Q3. So how to remove that Q2 and Q3? That we have to use that two inequality, that is for Q2 and Q3 in Q1, and after that we have to apply Arden's theorem to remove it. Okay. Now apply the value of Q1 and Q2, apply 2 and 3 in 1, we will get Q1 equal to Q1 AB plus sorry, it should be Q3 should be Q1 B, not it should be Q1 B, it should be Q1 B, it should be Q1 B. Okay. So it should be Q1 AB, then Q3 is Q1 BA plus lambda. Now take lambda initially, and then it will be, if I am rearranging only, then what I am getting, Q1 equal to, the statement is Q1 equal to lambda plus Q1 into AB plus BA. Now take an analogy with the expression as per the Arden's theorem. If I consider this one as R, this one as Q, and then this one will be R and this one will be P, then as per Arden's theorem what I can write it as, I can write it as a R equal to QP star. Then if I do this, then it will become what, that is lambda into AB plus BA star. Now this expression becomes independent of Q1. Now within this expression, if I put lambda inside it, then it will remain the same expression, right, AB plus BA star. Now this is the expression for Q1, and Q1 is the only final state. So this should be my answer, that is the regular expression for this finite automata. Now let us see another example. So for this, in the same manner, let us write down the expressions. For Q1 it should be lambda plus Q1 0 plus Q3 0, only these two, right. Now for Q2 it should be Q1 1 plus Q2 1 plus Q3 1, and for Q3 it should be Q2 0. I think only Q2 0, nothing else, right. Okay. So let us write this one as 1, this one as 2, and this one as 3. Now put the value of Q3 in Q2. We will get Q2 equal to Q11 plus Q21 plus Q201. This value I have replaced with Q20. Now take Q2 common, then what should I get? Q11, Q2 common, 1 plus 0 1. Now take an analogy with the Arden's theorem expression, that this one is R, this one is Q, this one is R, and this one is P. Then I should get Q11 Qp star, right, 1 plus 0 1 whole star. Now I get that Q2 equal to Q11 into 1 plus 0 1 whole star. Now put this value, take this value as 4. Now put 4 in 1, then it will become lambda plus Q10 plus Q30. Now change the value of Q3, the Q3 value will become Q200. Now put the value of Q2 over here, then it will become Q11, then 1 plus 0 1 star, then 0 0. Now take Q1 common, then it would become 0 plus 1, 1 plus 0 1 star, then 0 0. Now similarly, if I apply Arden's theorem over here, this one is R, this one is Q, this one is R, and this one is P, then my expression, I am writing this expression over here, then it will become Q1 equal to lambda into 0 plus 1, 1 plus 0 1 whole star, 0 0. Now put lambda inside over here, then it will this one will be star, so it will remain same. So I can remove this one. So this is my ultimate expression for this problem. Now let us try with another problem that will boost up the confidence. Okay, so for this problem we can easily identify the equation for Q1, Q2, Q3 and Q4, right. So what is the equation for Q1? Q1 equation will be lambda plus Q10 plus Q40 plus Q30. Equation for Q2 that is Q21 Q41 plus Q11. Equation for Q3 that is Q20. Equation for Q4 that is Q31. So take this as 1, this one as 2, this one as 3 and this one as 4. Now what I will do, put the value of Q3, that is equation 3, in 4. in 4, then I will get Q4 equal to Q3 1, that is Q2 0 1. Now put the value of 4 and yes, only 4. So put 4 in 2, that is Q2 equal to Q2 1 plus Q4 1 plus Q1 1. Then it would become Q2 1 plus Q2 0 1 Q2 0 1 then 1 0 1 1 plus Q1 1. Now if I take Q2 common, then it would become Q1 1 plus Q2 1 plus 0 1 1. Now apply Arden's theorem over here. Apply Arden's theorem, then it would become Q1 1 into 1 plus 0 1 1 whole star, because this one is R, this one is Q, this one is R, and this one is P. So Q1 1 was 1 plus 0 1 1 whole star after applying Arden's theorem. Right. Now put Q3 and Q4 in Q1. Now let us remove this statement, or otherwise what we can do, that we can start it in another page. So my Q1 equation is plus lambda. Now if I change this, my Q3 will become Q2 0 0 and my Q4 will become Q2 0 1 0 plus lambda. Now take Q2 common from here, it will become 0 0 plus 0 1 0 plus lambda. Now we already get the value of Q2. Now put, what is the value of Q2? Okay, put this equation number 5. Now put 5, then Q2 replaces to Q1 0 plus Q1 1 plus 0 1 1 whole star, and earlier we got 0 0 plus 0 1 0 plus lambda. Now take lambda over here, then it becomes Q1 0 plus 1 1 plus 0 1 1 whole star 0 0 1 0. Now apply Arden's theorem over here, then I will get 0 plus 1 1 plus 0 1 1 whole star 0 0 plus 0 1 0. The entire thing will be on star and keep lambda inside it, then it will remain same. So lambda is not required right now. Now we got the value of Q4. Now put this value in value of Q1. Now put this value in Q4. Now we know that Q4 equal to what? Q4 value is Q2 0 1, and what is the value of Q2? Value of Q2 is 1 plus 1 into 1 plus 0 1 1. Okay. Q1 into 1 into 1 plus 0 1 1 whole star, then 0 1. Now put the value of Q1. I got the value of Q1 from here, then it would become 0 plus 0 1 1 whole star 0 0 plus 0 1 0 So this is my ultimate expression. So hope you understood this one, and you can try to solve more problems.